Let's talk about molecules and bonding. How do molecules actually form? Well, a molecule is just made up of two or more atoms. They can be the same, two of the same atom, or they can be different atoms of different elements bonding together. There's two basic types of bonding that occur to make molecules. Covalent bonding is when atoms are going to share electrons. And ionic bonding is when the electrons are actually getting transferred. So one atom is giving an electron or more to another atom. We'll talk about more about why atoms would share or transfer electrons in just a little bit. And in the last lesson, I know we talked about that atoms come together to form molecules, and that's true. However, when we're talking about sharing of electrons or covalent bonding, it is called a molecule. But when we're talking about electrons being transferred and the formation of ions, which lead to ionic bonds, those are called compounds. So technically the atoms are coming together. If it's a covalent bond, we call it a molecule. If it is an ionic bond, we call it a compound. But the Bohr model explains how electrons behave. It projects what may be happening in atoms. So as I mentioned before, electrons are constantly in motion, and we know that they don't all have the same energy. They reside in different energy shells. But what we're interested in today is bonding, because this is what makes molecules, and bonding is always determined by the electrons that exist in the outer shell, and we call that outer shell the valence shell. The reason that chemical bonds form, either covalent or ionic, is simply because atoms desire to have their outer valence shells filled. So in the first energy shell, it is full with 2 electrons. The second energy shell is full with 8 electrons, and as we move out in energy shells, it's either 8 or more electrons from that point forward to fill the valence shell. But every atom desires to have its valence shell filled. Now, if we look at the periodic table, one thing I want to point out to you is you can tell about the valence electrons of an atom based on where they exist in the periodic chart. So this first group right here all has the same structure in their valence electrons. Okay, they're group 1, and as we'll see in just a minute, they have 1 electron in their valence shell. I'm going to talk about a couple of other groups, and that is this one here, group 18. These have a full valence shell, and they're called inert, which means then they're called inert gases because they don't react. They're inert. Okay? Sometimes they're called the noble gases. And the reason that these are inert and don't react is because they have a full valence shell. They don't need to bond with other atoms. They already are satisfied with their full valence shell. Now, if we look at the group just next to the noble gases, this group here, these guys have 7 electrons, or this one has 7 electrons in its valence shell. As you move down, every one of them is going to be lacking 1 electron in their valence shell. They just need 1 more electron to be happy and complete. Now let's talk about covalent bonds, and we'll look at some examples about how covalent bonds occur. So as I mentioned, these are bonds occurring between atoms that are actually sharing electrons. And a good example of that is water. So we're going to go through an example of how water covalently bonds. There are more than one type of covalent bond. There's both polar and nonpolar covalent. Let's look at water first. We'll take oxygen, and we're going to put the electrons, we're going to fill the electrons in their shells. So we need to know how many electrons does oxygen have. Well, here's oxygen, and we see that the atomic number for oxygen is 8, which means there are 8 protons, and for an atom from an element that's electrically neutral, that means there are 8 electrons. So we have to fill these electrons in their shells. Oops. So let's say in the first shell around oxygen, we know that this first shell is filled with 2 electrons. So we'll place 2 electrons in the first shell. And then in the second shell, we only have 6 electrons left to place. And so we will put 1, 2, 3, 4, 5, 6. Okay? Oxygen is not happy because oxygen doesn't have a full valence. This second shell would be full if it had 8 electrons. So along comes hydrogen and another hydrogen. And let's look at hydrogen. Hydrogen here has 1 proton, 1 electron. So we will only have 1 shell, which happens to be the valence. It is the only shell, it is the outer shell. And that 1 electron goes in that shell. Well, in this first shell, it would be full if it had 2 electrons. However, it doesn't, it only has 1. But what happens here is that hydrogen and oxygen can share a pair of electrons. And when they do that, they both get credit for both electrons. So if oxygen gets to count all 6 of its electrons, plus these 2 from hydrogen, now it has a full valence. And the same goes for hydrogen. It counts its electron plus the one that it's sharing with oxygen. That's 2. That fills the valence for the first energy shell. So this is why water is a molecule formed by sharing electrons, because it works to fill the valence electrons of these atoms. Now let's talk a minute about what I mean by polar covalent and nonpolar covalent. Every atom has a certain affinity for electrons. And by affinity, I mean how closely they hold those electrons. There's a term that describes this, and it's called electronegativity. Okay, so this is an atom's affinity or pull for the electrons. The more electronegative an atom is, the more tightly they're going to hold on to the electrons. The less electronegative, the more that they are likely to give up electrons. So you can think about in a covalent bond, the electrons are always shared. Okay, that's the definition of a covalent bond. But sometimes they're not shared equally. So if you think about tug of war, and in a tug of war, there's the knot in the middle of the rope, and as it's pulled back and forth from either side, if you have an uneven matchup, and so that knot stays closer to one side than the other, that would be like the polar covalent bond, where one atom is more electronegative than the other. Therefore, it keeps the electrons more of the time and doesn't allow them to be shared equally. With water, what happens is that oxygen is very electronegative. Hydrogens are not nearly as electronegative. So these 2 electrons that are shared between oxygen and hydrogen actually spend much more time. Remember, they're in motion. They're not a stationary, static thing. They spend much more time around oxygen than they do hydrogen. Well, it doesn't create a charge. It's not an ion. However, it makes the oxygen molecule partially negatively charged because it gets the electrons, which are negatively charged, more of the time. It makes the area of the molecule where the hydrogens are present partially positively charged. Okay, it's not charged, it's just got a partial charge there. And that's because the hydrogens retain their positively charged protons all of the time, but they don't retain their negatively charged electrons all of the time. It's shared more, it spends more time around oxygen. So that's a polar covalent bond. The nonpolar covalent bonds are a lot easier to imagine. That is when the 2 atoms that are sharing the electrons have essentially very similar or the same electronegativity. So any diatomic molecule, meaning 2 atoms of the same that are bonded together, like 2 oxygen atoms bonded to form oxygen gas, those would be nonpolar, equal sharing, no partial charges. Let's move on to ionic bonds. In an ionic bond, you actually have an electron or electrons that are given from one atom and taken by another atom. So there's no sharing going on here. We have a complete transfer. And when that happens, what is formed are ions. So we have a cation, which just think the T looks like a plus sign, so that makes it the positive ion. And we have anions, which are the negatively charged ion. Sodium chloride is an excellent example of something that is an ionic bonded molecule. So let's look at this. So we have sodium, and based on this description, is giving one of its electrons to chlorine. And what I want you to see is the reason that this occurs is that sodium is not nearly as electronegative as chlorine. Chlorine is very electronegative, but also look at if this shell is sodium's valence shell, it has one electron in its valence. If it just loses that electron, now this shell becomes the valence and it's a completely full valence shell. Chlorine, on the other hand, has 7 electrons in its valence shell. It just needs 1 to be happy and have a full valence. So by accepting this electron from sodium, it has a full valence shell. Now let's look at the periodic chart just so we can see where sodium and chlorine lie on the periodic table, and we can look at how do we determine that they actually have 1 valence and 7 valence electrons. Okay, so sodium, we see here, has an atomic number of 11. Chlorine has an atomic number of 17. We have 11 electrons, because 11 protons, 11 electrons, and we have 17. So remember, if we fill, all they're showing us is the valence electron for sodium. But if we drew all of the shells of sodium out here, the first shell would have 2 electrons because it's full with 2. Okay, we still have 9 left out of that 11. So the next shell would have 8. Okay, that's only 10 electrons. We have 1 more. And this is the valence shell that you see with the 1 lone electron. So as sodium gives this electron up, the valence shell now is this second shell, which is a full valence. Let's do the same thing for chlorine. Okay, we have 2 that fill the first shell, and then we have 8. That brings us to 10, which leads us to our valence shell that has 7. And by accepting this electron from sodium, now chlorine, or chloride, has a full valence shell. But when this happens, this creates these ions that I mentioned to you, a cation and an anion. This is a cation, and this is the anion. And the cation is positively charged, the anion is negatively charged. How do I know that those are the charges on sodium and chloride? Well, sodium is still going to have 11 protons, which is 11 pluses in the nucleus. But it no longer has 11 electrons. It gave 1 up. It only has 10 electrons. So there are 11, I don't know why I keep writing an H, 11 positive charges and only 10 negative charges. 11 minus 10 is plus 1. So it's a cation with a plus 1 charge. We would write this sodium plus. That indicates that it is a positively charged ion. Chlorine had 17 positively charged protons. It started with 17 electrons, but it gained an electron, so it gained a negative. So we have 17 minus, now we have 18. So chlorine, or chloride, excuse me, is written this way. But when you write them together, just NaCl, because the charges there cancel one another. it is the attraction of the charges of the ions that hold the ionic bonds together. So remember, covalent is a shared bonding, and ionic is due to transfer that causes these positively charged ions, and then opposites attract, therefore creating the bond.